Hi, ladies. We're getting ready to start chapter 5 today, and hopefully, you guys enjoyed a little bit of a long weekend with not having classes on Friday, and we had awesome weather, so that was fantastic. And I understand we're getting ready for another cold spell, so crazy weather here. So, outline today is same as normal. But there is no prime time. I'm going to go over stuff from last time, and I got quite a few questions, so I'm going to try to answer all of those. Some of them were more general. You'll have to let me know if I answer them as I'm going through things. So first thing is prayer. I have a number of prayer requests that looks like they've been added, so I wanted to be sure that I put this back up here. So a lot of people whose families are being affected, some good things, some new babies, that's awesome. And you've probably seen that this week Beaumont has started some things for our seniors. There were some deliveries made at the end of last week, and they're doing some sharing out on Facebook with celebrating seniors. So let's go ahead and get started with our prayer. So in the name of the Father, and the Son, and the Holy Spirit, amen. Lord, I'm weary and don't know when this race will end in my life. I feel like I've been running forever trying to outrun this trial. Help me to stop trying to outrun my pain, but rather run with endurance the race that you have set before me. I know that because of you, I am ultimately a victor over the trials in my life. I know that nothing in this world can separate me from your steadfast love. Please give me a measure of your love today. Give me the strength to endure this trial. Thank you for your love for me that never ends. And thank you for the crown of joy that awaits me forever in your kingdom. In the name of the Father, the Son, and the Holy Spirit, amen. So we did that one a few weeks ago when we were at the very beginning of this time at home, and I was looking back and trying to see if there was something else that spoke to me today, and that one did, because I feel like we're still running. It's not quite like it was at the beginning before spring break, but still just trying to make it through to the end. So speaking of the end, there are only 7 B days left, which is kind of exciting, kind of sad, kind of overwhelming, everything all at the same time. So what we've got left is a lot of nomenclature practice. So I've outlined the remaining classes. So this week, Tuesday and Thursday, we're doing all sorts of ionic compound naming. Thursday should be a shorter day, so you have a little bit of extra time to work on some of your one-pagers for the test. Monday, May 11th is going to be your entire Chapter 4 test due date, and I'll go over details again in just a bit. And that will also be shorter to provide some time for you guys to work on the test. Your class content is just going to be filling in some note sheets for 6.1 on 6.2 on material you've seen before. Wednesday, we're going to work on covalent naming, and Friday, we'll do a little bit of balancing equations, and then the last week will be nomenclature of acids, and then kind of an overall practice. So normally I give short daily quizzes each day in class, and this material is covered on the final, but since there's no final, not exactly sure what we can do. Some people need some additional test grades to kind of bring their grades up, and I'm not exactly sure what to do or how to handle that at this point. If you have any thoughts about that or concerns about that, please put some information down on the survey today. So going over details on your Chapter 4 test. So there are 3 parts, just like last time. You've got 2 separate one-pagers. One of them was about determining protons, electrons, and neutrons, like filling out the tables and the information that we've been doing. And then the second one is basically a summary sheet of the other information that was covered in the chapter. So look at these as being basically your cheat sheets for the test. Okay, but make them nice, make them legible, make them helpful to you. So I'm going to have those due at 8 a.m. on Monday morning. So you'll have them done before you take the test. And then you're going to take the online portion of the test, and you'll it will be just like last time, available from 12:30 to 3:30. I'm still in the process of putting questions into the question bank. And once I kind of finish that up, I'll be able to give you more details, which should be on Thursday. And during your online quiz, the last two questions are going to assign you your isotope and your ion that you're actually going to be building your models of. And then I'm going to request that you email me and or post up to P-Learning the photos of those two models by 8 p.m. I think you should have no problem getting everything done. I do know that there's at least one student who's taking an AP Gov test on that Monday, and I've already emailed them. If you are also taking your AP Gov test on Monday, email me and we can work out different arrangements for you to be taking your test. All right, so a little update. So these are some pictures from New Zealand. There is some pictures here of Christchurch, and this is the area that had went under the earthquake. So it was really sad when we saw after their earthquake there that some of this area was destroyed, but it was very beautiful. We had a very nice day in Auckland, and they have a sky tower. The mountains were gorgeous. We went to a place, and they're really known for their lamb. A lot of lamb that we even purchase in the grocery store. Some of it comes from down there. And I had no idea that there were so many different kinds and they looked different. So I shared part of that picture here. And this was a natural geyser springs place, and a little bit like Yellowstone, but down in New Zealand. So a little bit about few pictures from there. So onward to chapter 5. So the first thing we're going to do is binary ionic compounds. So binary means that there's two elements binding together with using their charges. So you have a positive and negative charge kind of coming together. And so this is chapter 5, and then chapter 6 down here talks about chemical reactions, evidence of a chemical reaction, which we've already covered, writing chemical equations from the perspective, what's a product, what's a reactant, and the thing that we have not done is balancing chemical equations, which we'll do a little bit of to at least get you some exposure of it before next school year. Okay, little chemistry video. Last time I told you, or I showed you a video, and we watched part 1 about the vanishing water, and here is part 2. first time I saw that demo with sodium polyacrylate, I was kind of surprised because I hadn't seen that before. But it is what's used in diapers to hold the water, and because it can hold so much water, it makes a really good trick there. Okay, there we go. Okay, so going over some homework from last time. So green page 27, the right side. I did a number of these. I'm going to go over the rest of them today. So number 2, you're given the mass number is 48. The neutrons is 26. So the number of protons will equal 48 minus 26, which is 22. So the element is titanium. The atomic number is 22. We have nothing to give us any indication that there's any charge, so it's going to be 0. So there's the same number of electrons. So you can write the isotope notation. Number 4, the atomic number is 86. The charge is 0. The element is Rn. And number of electrons and number of protons are equal. It's 86 because the charge is 0. The mass number, we're going to have to go to the periodic table because we aren't given anything else, so it's 222. So the number of neutrons is 222 minus 86, which is 136. Number 5, the atomic number is 53. Electrons are 54. So if the protons are 53, element is iodide. But the charge is not 0 because we know electrons are 54, protons are 53. So there's one more electron than proton, so the charge is minus 1. So the mass number is 127, and that is from the periodic table. So the number of neutrons is 127 minus 53 equals 74. All right, so the next one, number 7. Protons is 20, electrons is 18. So the element is calcium from the periodic table, and the mass is 40 from the periodic table. So neutrons is 40 minus 20, which equals 20. The charge is not 0 because protons and electrons are not equal. So this tells us that it's 2 and it's positive because there's more protons. Number 8, Se with charge minus 2. So from the periodic table, you can know that the atomic number is 34. The atomic mass is 79. The number of neutrons is 79 minus 34 equals 45. Since the charge is minus 2, there are more electrons than protons, and the electrons is going to be 2 different from the 34, so that gives us 36. And then the last row, number 10, protons is 15, electrons is 18, element is phosphorus, atomic mass is 31 from the periodic table. Number of neutrons is 31 minus 15, which equals 16, and there's more electrons than protons, so the charge is minus 3. So at the bottom here, you can see the ones which are cations. 6, 7, and 9, because those are positive charges. The ones that have neutral atoms, which have no charges, 1, 2, and 4. And then the ones that have negative charges, 3, 5, 8, and 10. Okay, page 28. We did 1 through 4 and 13, 14 last time. So number 5. There's 18 electrons, so it's the same as the number of protons, so there's no charge, and it's argon, so it's an atom. Number 6, there's 18 electrons, and it said there's 17 protons, so there is a charge, and it's -1 because there's one more electron than proton, and it's an ion, and it's chlorine. Number 7, there are 17 electrons, 17 protons. There's no charge. It's an atom, and it's chlorine. Number 8, there are 18 electrons, 20 protons. So there's a charge, and it's +2 because there's more protons, so it's positive. So it's an ion, and we can identify it as calcium from the 20 protons. Number 9, there's 1 electron, 1 proton, no charge, and it's hydrogen. Number 10, 1 electron, 1 proton, no charge, and it's an atom, and it's hydrogen. And then number 11, there's no electrons, 1 protons, and so their charge is positive 1, and it's an ion, and it's still hydrogen. And number 12, we've got 2 electrons, 2 protons, no charge. It's a helium atom. Hopefully that clears up some questions that you might have had. Okay, and then 29. We did 1, 2, 3, 4, 5, 6, and 7. So starting with number 8, protons are 24, neutrons are 52 minus 24, which is 28. There's no charge given up in the upper right-hand corner of the symbol, so electrons is also 24. Number 9, 24 protons. Neutrons 52 minus 24 equals 28. It tells us there's a charge is plus 2, so there are more protons. So electrons equals 22. Number 10, 24 protons. Neutrons are 53 minus 24, which gives us 29. There's no charge, so electrons equals 24. Number 11, protons are 25, neutrons are 52 minus 25, which is 27. There's no charge, and the electrons equal 25. Number 12, protons equals 78, neutrons equals 197 minus 78, which is 119. There's no charge given, so electrons are 78. Number 13, protons are 79, neutrons are 197 minus 79, which is 118. And electrons are 79 because there's no charge. Number 14, protons, there's 83. Neutrons are 197 minus 83, which is 114. And electrons are 83 because there's still no charge. 15, protons are 86. There's no charge, so electrons are also 86. Neutrons are 197 minus 86, so that gives us 111. Kind of interesting in this row, there's all these things that have an atomic mass of 197, but they're all different elements. Number 16, there are 11 protons. Neutrons are 23 minus 11, which is 12. It's a positive 1 charge, so there's more protons, so there are going to be 10 electrons. Number 17, 12 protons, 24 minus 12, which equals 12, so there's 12 neutrons. There's a positive 2 charge, so that means that with 12 protons, you're going to end up with 10 electrons. Then 18, there are 8 protons. Neutrons are 16 minus 8, which is equal to 8. The charge is minus 2, so there's going to be more electrons. So that means 8, and we're going to end up with 8 plus 2, so that's 10. So 10 electrons for number 18. Then number 19, the number of protons is 9. Neutrons are 19 minus 9, which is 10. And there's a negative 1 charge, so there's more electrons. So we've got, we're going to end up with 10 electrons. Okay, ladies, so since I can't see your faces and you guys can't answer me questions this way, anything that doesn't make sense, please jot it down, send me an email. That's the only way I'm going to be able to help answer questions that you guys might have on this. Okay, a couple other questions not on homework that people were asking after last class, kind of like difference between terminology. So I pulled up another picture. So periods and groups. So periods are the numbers that go down on this side. So anything in this row is period number 1. Anything in this row is period number 2. This row is period number 3. So if you're looking at calcium right here, number 20, and you want to know what period it's in, it is in period 4. Groups are these numbers are going across the top, numbering 1 through 18. But we do give certain groups special names, and we still call these columns families. But But like the first column, we've got alkali metals, alkaline earth metals, and then over on the other side, we've got halogens and noble gases. Those are special names for these groups because they have special characteristics. Somebody asked about the stairs, and if these were a slightly different color, you'd be able to see it here, but this is kind of like a stair step. Here, can you kind of see? You kind of go down each as a step. This is giving you an idea of the difference between where the metals are on the one side and the non-metals are on the other side. So we refer to this as the stairs. So these are the metalloids. Hopefully that answered people's questions. I also got the question of what's the difference between cations, anions, and neutrals. So cations, anything that has a positive charge. Anions, anything with a negative. And neutral is something that has no charge. And this refers back to something that we did in this packet, and it was on page 27 in the green packet. Okay, so I had you guys have this table for the models, and as I was looking at some of the answers in PowerSchool, there were quite a few errors, so I wanted to kind of back up a step and go over this again. So I had shown an example here of what it would look like with oxygen. So I'm not going to do that one again, but I want to start with the potassium. So K39, if we go and we look at the models that we built, which I had displayed in the last class, there is 1 electron in the outermost circle. Okay, so if you add more electrons to get to 8, you'd have to add 7. So that would mean that you'd have 7 more electrons than you would have protons, because you haven't changed anything about the protons here. So the charge ultimately would be -7. So that would be your answer to A. For column B, if we go back and start with 1 electron in their outermost circle, if we actually remove that one, the charge is going to be +1, and that would be the answer that would go in column B. For magnesium 24, there were 2 electrons in our outer circle. So if you want to get to 8, you have to add 6, which means that you'd have 6 extra electrons and the charge would be -6. Start over again with magnesium 24 and you still have 2 electrons in the outer circle, and we remove those, your charge is going to end up being +2, and that's the answer to B. So now some of you, this made perfect sense. You filled out your table. It was perfect. No issues. For some of you, some of the table was right and a few things were wrong. So if it doesn't make sense, try to take a look at it here and see where you made your mistake. This is not going to be on your test, but this leads into what we're heading into right now with trying to bond these things. So it's a good idea to kind of get in your mind, if you were way off, maybe what mistake you might have been making. So pause the video, take a look, and see if it makes a little bit more sense now. Okay, so moving forward, if I asked you the question, which of these would be easier? Would it be removing the electrons from the outer circle or adding more? So let's look at each line independently and kind of think about it. So in our first example that I gave you, the oxygen 16, if we have this -2, it gained 2 electrons. That's what happened in this one area. And in the other one, if we got to +6, it was because we lost 6 electrons. So just in general, which do you think would be easier to happen? Do you think it would be easier to gain 2 or lose 6? So I'm hoping that you would say that it would be easier to gain 2, okay? And there's a reason I'm kind of going through all of this, because it does lead us right into what we're heading into. So while it would be possible to lose these 6 electrons and still have an outer ring that had 8, because for whatever reason, the world was designed, everything likes to have 8 electrons in its outermost circle. That's when it's happiest, that's when it's the most stable. So as we start talking about how chemistry and chemicals combine, to form lots of other chemicals, they're going to try to get to 8. So in the case of oxygen, it would love to gain 2 electrons from someplace because that would allow it to have 8 in its outermost circle. So if we look at the next line, we've got potassium. Would it be easier to gain 7 or lose 1? Well, it would probably be easier to just lose 1. Magnesium, gain 6 or lose 2? Well, it's going to be easier to lose 2. Boron, gain 5, lose 3. It should be easier to lose 3. And then when we get down here, gaining 3 or losing 5, oh, now it's going to be easier to gain 3. And sulfur, gaining 2 will be easier, and chlorine, gaining 1 would be easier. So it depends on where our elements are on the periodic table. So what I'd like you to do is pull out your periodic table, and above the column where you find potassium, write +1, all the way up at the top of the column. And above the column where you find magnesium, write +2, and do that for these other ones. And while you're doing that, I am going to move into the video. So we're going to watch a short video, and it's going to be really important to go through and label your periodic table with the information from this video, because this is what we're going to use for a while, and you're going to want to know this next year because it's going to be really important. All right, so here we go. This video is going to go through the periodic table and take a look at the elements and what charges they form. We're going to start off all the way over here on our very first family, the alkaline metals. We're also going to include hydrogen in this case, and we're going to have this entire family going to be forming a +1. Okay. Bump over to the next one, alkaline earth. All of those down there, that is a +2. We're going to skip this middle section for right now. We're going to head over to the other side, the boron family. And we're going to be looking at boron, aluminum, and gallium, just those 3. And they form a +3 on that. Okay. Next family over, the carbon family, we're going to skip it for right now. They do something else instead of forming charges. Nitrogen family over here, we're going to do the first 3, nitrogen, phosphorus, and arsenic, and those are at a -3. Next family over, we're going to include the first 4, oxygen, sulfur, selenium, and tellurium, and those are all a -2. The halogen family, all the way down, and those are a -1. And then the noble gases, they have all of their electrons they need, and so they don't do anything in terms of charges. They form a 0. So now what we're going to do is we're going to take a look at this middle section, okay? And these ones change their charges. And so we can't predict what exactly the charge will be on a certain element, except for 2 elements, 2 exceptions, okay? The first one is zinc over here. Zinc always forms a +2, and silver always forms a +1. The other thing here is these metals that we did not highlight here, they are special in the case that they act like a transition metal, and they change their charge, so they will have to have some indication as to what they are, okay? And if you want to take a look at which ones we're dealing with indium, germanium, tin, antimony, bismuth, lead, and tin, okay? All of those are going to act like the transition metals where they change their charges. So now we're going to take this information about the charges and we're going to apply it to writing formulas and also naming various compounds. All right, so hopefully you were able to copy all that information down as she went. If not, just back it up. going to go through. No, it didn't pause. Periodic table. All right. So I found that video. Actually, another student found that video in the past, and she does that very quickly and very succinctly. So I felt that that was a good way to do it. And she has it set up where she had her, I think, her camera videoing on top of her paper. So it was, and I don't have any set up like that yet. All right, so we are going to use that periodic table, and we are going to do some a little bit of trying to figure out information about how some bonding will go. And so you're going to want blue page 30. So it asks us here for using the oxidation states, trying to predict the binary compound that can form from these two elements. So if we find sodium on our periodic table and we look at what we just wrote, it is going to have a +1 charge. And if we look at where oxygen is, it is going to have a -2 charge. So what I want to do is open up this app and show you. So we have Na with a +1 and oxygen with a -2. And if we take this 1 and bring it down here, and we take this 2 and we bring it down here, we'll write Na2O. That is the compound that this is going to form. And so that is what you would write down here, Na2O. So that's their example. So let's do the next one. So the next one is Na, and if we find that on the periodic table, it'll be in the +1 column, and Cl will be in the -1 column. And we're going to do the same thing. We're going to take the numbers, but not the signs. So we're going to write 1 and 1. So we end up with NaCl. And when we have 1 and 1, they're the same. We don't normally write 1, so it's going to be just NaCl. So that is actually sodium chloride, which is table salt. Okay, let's look at another one. So number 3, we've got calcium, which is in the +2 column. We've got oxygen, which is in the -2 column. And when we look at these and we crisscross them, we're going to get Ca2O2. Since they're the same, we can reduce them, okay, just like you would in algebra, because they're divisible by the same number, and they are the same number, so it would be CaO. So that's number 3. And ladies, you're going to want to be looking at your periodic table and going through these with me as I go through them. So if you're not, pause the video and work on these together. So here we've got calcium +2, chlorine -1. So when we crisscross, we get Ca, Cl2. So that's what we've got there. Then I'm going to skip down and I want to do number 13. So number 13 is Fe, and they tell us that it's +2 because it's in that transition metal area where we don't know the charge, but we've also got oxygen. And if we look in our periodic table, oxygen, we wrote down -2. So when we crisscross those, they're both going to have a 2. And since they're both the same number and they're divisible by 2, we can reduce it, so it'll be FeO. So that's 13. And then 14, they also give us iron. This time they tell us it's +3. Oxygen is still -2. And now we're going to crisscross, so we've got Fe2O3. Okay, so pause the video, do the rest of these right now, and I'm going to pick up in your Chapter 5 packet when we get started in just a moment. Okay, so page 5 in your chapter 5 purple packet, you're going to be filling out things as I kind of read through the pages. So we're going to start with names and formulas of ionic compounds. It says recall. You don't know that yet, but recall ionic compounds are composed of a metal and a nonmetal. Naming these compounds is easy if you follow 2 rules. The name of the metal, the cation, comes first. Its name is unchanged from the periodic table of elements. And number 2, the name of the nonmetal anion goes last. It keeps its ionic name, that is the name that ends in IDE. So remember, metals are on the left side of the periodic table, and nonmetals are on the right. So for example, table salts, sodium is NaCl. So the name of the metal is sodium ion. The name of the nonmetal ion is chloride ion. So if you put them together and drop the word ion, you got sodium chloride. So AlCl3, the name of the metal ion is aluminum ion. The name of the nonmetal ion is chloride ion. Add them together and you end up with the name of the compound being aluminum chloride. So you're changing the chlorine to chloride. So it doesn't matter that there are 3 chlorine atoms involved, the name follows the same formula. So try these in this table. So in the first one, the metal ion is calcium, and the nonmetal is fluoride. So the compound will be known as calcium fluoride. So can you do the next one? What's the name of that element? Potassium. And what about S? It's sulfur, and it will become sulfide. So when we put them together, we get potassium sulfide. Then we have aluminum and oxygen, and that becomes oxide. Putting them together, we get aluminum oxide. Next one, we've got lithium. And then that's bromine, so it becomes bromide. Putting them together, we get lithium bromide. Then we've got calcium. And we've got phosphorus, which becomes phosphide. And that becomes calcium phosphide. Next one is sodium. And that's also phosphorus, which becomes phosphide. So the compound name is sodium phosphide. Hopefully you're kind of seeing the pattern, getting the idea of how this all goes. Most students find this to be pretty easy. Once you start naming them, you recognize that fluorine becomes fluoride and phosphorus becomes phosphide. So pause the video if you need to and finish working on this page. So now moving on to page 6. So writing chemical formulas of ionic compounds. So when elements form ionic compounds, the electrons move from the metal to the nonmetal. So the positively charged metals are attracted to the negatively charged nonmetals, and this attraction forms the ionic bond. So ions will continue to attract other ions until all of the charges are balanced. That is, until every positive charge is balanced by a negative charge. So in the compound, the sum of all of the charges must be 0. So while we can have ions floating around looking for something to bond to, when they form in a compound, the compound must be neutrally charged. So if we're going to do an example here, what is the chemical formula for magnesium chloride? So we're going to look at magnesium. So we're going to start with writing the elements and their symbols. So we've got Mg and Cl. So step 2, place the ionic charge of each ion above the symbol. So magnesium is going to be a +2 and chlorine is going to be a -1. Step 3, determine how many of each ion is required to bring the total sum of the charges to 0. The sum of the charges must always equal 0 in an ionic compound. So we've got to fill in the blanks here and figure it out. But it'll end up being, we need 1 magnesium and 2 chlorines. And that will now sum to 0. Step 4, write the chemical formula by writing the number of each ion needed to create an overall 0 charge as the subscript. If the subscript is to be 1, just write the symbol since the symbol indicates 1. So you end up with MgCl2. All right, we're going to try one more. Calcium chloride. You're going to have calcium is +2, chlorine is -1, and you will need 1 calcium and 2 chlorines. So when you write it with its formula, you're going to write CaCl2. So now, since I already kind of introduced the other method of doing this, I am not going to spend any time on writing the other ones that are in this table. You're welcome to pause and copy it down if you want. Okay, so the crisscross method, which we kind of already did back in the blue packet on page 30 today. So the previous method works, but it may not be the most efficient way of determining the chemical formula for an ionic compound, and here is the other method. So we've got MgO, and you write the charges. So write the symbols of the elements and their ionic charges. Step 2, crisscross the numbers of the ionic charges so they become the subscript of the other element. So you're going to put the 2's on the other by the other ones. So we end up with Mg2O2. And step 3, if needed, reduce the subscripts to the smallest possible ratio. So Mg2 and O2 will become MgO. So let's do some more of these. So calcium bromide. We know we're going to have Ca and Br. Ca is in the column where it's going to have a +2 charge, and bromine is going to have a -1 charge. Crisscross them. We're going to end up with CaBr2. Next one, aluminum iodide. Al is +3, iodine is -1. Crisscross them. Remove the 1. We've got Ali3. Sorry, that kind of overlapped each other, but it's Ali3. Magnesium sulfide, Mg +2, and sulfur is -2. So Mg2 and S2, and when we simplify and reduce, we get MgS. So pause this, and try to do some of these on your own, and I will go ahead and go through the rest of these on this table. But if you can do some of these on your own, you'll find that to be very helpful. The lithium phosphide, Li-P, you're going to crisscross, you end up with Li3P. Calcium chloride, you're going to get CaCl2. Calcium oxide, you're going to have CaO. Lithium iodide, you're going to have Lii. Potassium chloride, you're going to have KCl. All right. In elements with multiple ionic charges, chemists have discovered that some elements have 2 stable ion charges. These ions are named with a Roman numeral in bracket placed directly after the element name. Roman numeral in the brackets tells us the ionic charge. For example, a substance commonly used in the lab is created with a copper ion that has a +2 charge, so its name is copper 2 sulfate. So notice how the ionic charge goes before the name of the anion. So we put it right after the ion that its charge is associated with, so it's in between the two. So we're only going to do this when there are multiple charges. So it's only going to be the things that you labeled on your periodic table that could have multiple charges. So let's do some examples here. So you're going to want to pause the video and write these down. So these are really the most common ones. So for copper, you get a +1 and a +2. Iron, a +2 and +3. Lead has +2 and +4. Manganese, +2 and +4. And tin, +2 and +4. And no, I do not expect you to memorize these. No, your teachers next year are not going to expect you to memorize these. But it is important that you recognize that all of these have multiple charges. It's not possible to predict. So let's do some of these using the crisscross method. So copper 2 plus bromine. So if we look at these, copper has a +2, bromine is in the column where it's -1. And when we look at the formula by crisscrossing, we get CuBr2. And then the formula name will end up becoming copper 2 bromide, because we're going to change the bromine to IDE like we did with all the other ones. Next one, iron 3 plus oxygen. So we've got Fe is +3, oxygen is -2. We do the crisscross, we get Fe2O3, and the name is going to be iron 3. Oxygen becomes oxide. The next one, iron 2 plus oxygen. So this time we have Fe and O, and charges are +2 and -2. Crisscross. They're the same. We're going to reduce. It becomes FeO, and it becomes iron 2 oxide. Then we've got manganese 4 plus chlorine. So we've got Mn, which is +4, and chlorine, which is -1. So we crisscross. We end up with MnCl4, and it's manganese 4 chloride. And then the last one in this table is lead 4 plus oxygen. We've got Pb, which is +4, O is -2. Crisscross them. We get Pb2O4, but we can reduce it because they're both divisible by 2. So we get PbO2. And this is going to be lead 4 oxide. Okay, so what I'm going to have you guys do is go on pages 10 and 11 in here in your purple packet and work on these. Do as much as you possibly can. There's a column for the compound name. There's a column for the chemical formula. There's a column for the rough work if you need it to help you go in between the formula and the name, especially if you have to try to figure out the charges. So you've got two types here. You've got things that are going to need the number in brackets, and you're going to have things that you need to not have any of those numbers in brackets. So I just want to, I'm going to go back out here. So there are two types of things that we talked about today. One of them was these original ones that we look at the periodic table and we've only got a metal and a non-metal, and the metals only have one charge, and we can come up with the name following the method that we did at the very beginning where we were looking at these. And we can figure out the formula by crisscrossing charges. And the other one that we looked at today was when we had ones that had multiple charges because they were transition metals and they're in that area of the periodic table. And we have to write the Roman numeral in brackets afterwards, after the name. Okay, so I know this is challenging. I know that this is going to be, since I'm not there with you and I can't work through the examples as we go through them together, you're going to take a little bit of time to work on that. So work on pages 10 and 11 and take your time and be kind to yourself, okay? This is not always easy to get on the first try, and I understand that. But this I felt was really important for you to get exposed to this year and for us to practice as much as we could, because you're going to have to have it mastered next year, because you're going to be using it a lot. So for today, your additional practice, pages 10 and 11, these are required. You must try these, okay? Additional pages in your packet for practice are pages 16 through 20. Now, I'm not saying these are not all assigned, okay? There are some in here that have polyatomic ions in them, and we haven't talked about that because we're going to talk about those next time. There are some that have more than 2 elements, so they're polyatomic. But I want you to know I made this packet with the intention of you having extra practice, more than you're going to do here with me, so that you have them over the summer and you can look at and get yourself really well prepared for junior year. So your turn-in work due Thursday morning is going to be your green packet, page 30, and your purple packet, pages 5 to 11. And you do not need to turn in, if you do any extra ones, you don't need to turn them in. I am going to be assigning some of those pages and some sections of those pages in the upcoming days that we have left. And then you also have your survey, okay? Yeah, that's it. Okay, bookwork, optional bookwork. Chapter 4, we already had stuff with ions and compounds that, today I've done compounds that contain ions, which was 4.11, and chapter 5, 5.1 and 5.2. So this really covered 5.2 material, which was naming binary compounds with a metal and a non-metal. So looking ahead, I already provided an outline earlier in the video, so you have an idea of what's coming up. And next class, you're going to need the document named naming compound spinner and scissors to cut the 2 circles out. If you have a brad, that's really helpful. I put a picture of a brad in here so you'd know what it looked like. If not, I'm pretty certain that we can bend a paper clip to make it work like a brad so we can have this thing be a spinner. It's helpful in naming. And just a reminder, Curation Project, May 5th, which is the day you should be watching this video, you should have sent me an email with 3 more resources. And May 19th, there should be 2 resources, and that's your final Curation Project. So ladies, that's all I've got for today. So work with these compounds and these pages, and when you get stuck, go back over the notes. Go back and take a look at the ones that we've already done as examples. It will get easier with practice. Sorry, due to the timing and the time that we have right now, I don't have a lot of time to do more practice with you right now, but let's just see how it goes. So hang in there, ladies. I have the utmost confidence in you, and you guys take care.